Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to study about the blast furnace. Blast furnace is the device which is used for extraction of many important metals. The most common metals which have been refined and extracted with the help of blast furnace are iron and copper. Today we will take the example of iron and see the entire working of the blast furnace, all the chemical reactions which take place and exactly what happens at which part of the blast furnace. We'll start off by the diagram of blast furnace. So over here we have a diagram of the blast furnace. This is known as the opening point, which comes down to the throat. This is the body of the blast furnace. In the body of the blast furnace, all the important reactions take place. And after that is done, it comes down to wash. And at the end from the earth, we find out the molten iron and the slag. The molten iron is also known as pig iron. So what exactly happens over here is we start off by passing floor in it. Floor is passed inside the blast furnace. Now what is floor? Floor is nothing but it is made up of charge. What exactly charge consists of? Charge consists of iron ore or the ore of any metal which is needed combined with coke in it. Coke is coal. So what happens over here is we get the ore and the coke through the opening point of the blast furnace and it gets down into the blast furnace. Now we cannot simply throw away the entire charge at the same time. Therefore, there is one equipment which is applied over here, that is the double cup and cone method. So what happens over here is, imagine you have a cup and you fill the entire cup with the charge we have. Once the cup is full, it will tilt down. Once it will tilt down, it will put pressure on the cone which is there and this cone will fall down. If the cone is falling down a little, all the charge comes down and enters the blast furnace. And this keeps on happening till all the charge is utilized and gotten into the blast furnace. So with the help of the cup and cone method, we get to a point wherein little amount of charge gets into the blast furnace. So what happens when the entire charge gets into the blast furnace? We have two tubes over here. So what is the use of these tubes? These tubes helping to blast hot air into the blast furnace. So normal atmospheric air containing all the gases is heated to a very high temperature and this air is blasted into the blast furnace from the openings which are there down. So now we have the hot air coming up and the charge flowing down. The hot air from the down, the charge from the up will meet somewhere in the middle, and because of the charge meeting the hot air will lead to reactions. These reactions are generally combustion reactions and these reactions give in a lot of heat. So they are exothermic reactions. Whatever reactions happen lead to a lot of wastage. This wastage is of two types. If the wastage is solid or liquid, it will form slag and it will come down through the earth. If the wastage is gaseous, then we have a separate pipe over here. This outlet will let out all the waste gases. Working of the blast furnace. So what exactly happens in the blast furnace is the hot blast of air is introduced near the tubes into the furnace and the charge is fed from the top. Both of them meet somewhere in the middle. And the first reaction that happens in the blast furnace is between carbon and oxygen. The carbon which is present in the coke and the oxygen which is present in the hot blast of air. C plus O2 from CO2 plus 97 kilocalories. We have one carbon over here and one carbon over here, two oxygen over here, two oxygen on the product side. Therefore, this reaction is balanced. So carbon plus oxygen forms carbon dioxide and plus it gives 97 kilocalories. Only from the first reaction which is happening in the blast furnace, we get 97 kilocalories of heat, which is a lot of amount of heat. Now the next part is we have to trap the heat. The heat should not just go away from the blast furnace, and that is why we have carbon dioxide. Carbon dioxide is the gas responsible for trapping a lot of amount of heat, and since carbon dioxide is trapped in the 97 kilocalories of heat, this helps in the further reactions. When CO2, which is in the gaseous form, will obviously move up because it's a light gas. So when CO2 goes up, it gets reduced to carbon monoxide by coke present in the charge. We will see the reaction for that as well. CO2 plus C, this is carbon dioxide which is formed from the previous reaction, and this is the C, the carbon which is present in the coke which is fed from the top. This CO2 plus C forms 2CO, carbon monoxide. So 1 carbon dioxide plus 1 carbon forms 2 carbon monoxide minus 39 kilocalories. This is an endothermic reaction. Now, since it is an endothermic reaction, we do not need endothermic reactions because we need the heat. But this CO which is being formed is very useful. We'll see that in the further reactions. Now, let's discuss the balancing. We have 2 carbons on the reactant side, 2 carbons on the product side, 2 oxygens on the reactant side and 2 oxygens on the product side. Hence, this reaction is well balanced. The temperature of the blast furnace goes on decreasing from bottom to top. As of now, we have seen different reactions, but all these reactions were only used to set up an environment, to make gases which are useful for trapping heat, for actually generating heat. Now we will see the exact reaction with iron to get pure iron. So we over here have ferrous oxide, Fe2O3, ferric oxide plus 3CO. So to this oxide of iron, I am adding 3 carbon monoxide which was already made in the previous reaction. This carbon monoxide will form 2Fe plus 3CO2. This 2Fe is in its pure form. So we have 2Fe plus 3CO2. But we have to see here that it is a reversible reaction. And why is it a reversible reaction? Because in the blast furnace we have a lot amount of heat, many reactions going on. So for this it is important for us to make sure that this Fe will not reverse back. First, let's see the balancing of the reactions. We have Fe2O3. So over here we have 2Fe. Over here also we have 2Fe. Let's count the number of carbons. We have 3 carbons. Over here also we have 3 carbons. The number of oxygens are 3 plus 3, 6. And over here we have 2 into 3, that is 6. So this is an overall balanced reaction. Since I had told you that this is a reversible reaction, why? Because the process of reduction, a part of metallic iron, reacts with carbon monoxide again to form ferric oxide. The backward reaction can be prevented by continuous supply of hot blasts of air. Flux or lime forms slag with impurities. Now what do I exactly mean by slag? Slag is nothing but all the impurities which are fused in together. So now over here, where will I exactly find slag? In the blast furnace. The entire reactions take place in the body of the blast furnace. All the waste gases will go up through the outlet of the waste gas, and all the remaining impurities and the molten iron are formed over here. Always remember, all the impurities, the gangue, the dust, the rock and the salt particles are always lighter than the main metal. The main molten metal will always be heavier and have more density than all the gangue and the impurities present in it. So now over here in the earth, we'll make 2 outlets. The outlet which is below, it is for molten iron because it is heavy. It will settle down. It will be on the surface. Whereas the outlet which is over here at some height is for the slag. This entire slag will come out through this outlet, and the pig iron or the most pure form of iron that we will get after the entire process in the blast furnace will come out from this below. Thus, the blast furnace has 2 important features. The first one is to reduce the metallic iron, and the second one is to remove the impurity in the form of slag. We have iron in the form of Fe2O3 generally, which is ferric oxide. This ferric oxide gets combined with carbon dioxide, carbon monoxide, and we get it in the form of pure iron. Again, it is not 100% pure iron, but we get it in one of the most purest forms, and all the other impurities are taken out in the form of slag. The molten iron from the blast furnace is collected in molds and on solidification forms pig iron or cast iron. Once the iron is let out of the blast furnace, it is very hot. It is in its liquid state. It needs days and days to set it and get it solidified. And once we get that solidified iron, that is known as pig iron or cast iron. It is the most impure form of iron containing highest percentage of carbon, which is 2 to 5%, which makes it hard and brittle and hence unsuitable for commercial use. So we get it in the most impure form, but to make it pure, either we can alloy it or we can start electrolysis of it. Electrolytic refining will make it more refined, and the 2 to 5% of carbon which is present will also go away. Pig iron is used to make wrought iron and steel. Wrought iron is the purest form of iron. It is the strongest form of iron. It has minimum number of carbon content in it. And again, it is used for making steel. So over here we studied the working of the blast furnace. Thank you so much for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda.